So we see when you look on the Raptor work and the pseudocode, you do the same, right? You also work exactly the same here. Everything declaration here and everything with interrupter here, the same. Call the housekeeping here. Go to the function housekeeping, and when you call to go function housekeeping, you run to the you jump into the housekeeping here, right? Run to the housekeeping, do everything inside the housekeeping here. Exactly the same. Exactly the same. Any questions so far? Now see, if I run it here, I go to the main module. Run it here. Okay, you see, the most important part is that in the housekeeping, you get the name. And in order to check if the condition is true, right? Change the true here. So I put the name here. See, to check the condition is not equal to x, right? So now enter the gross of the employee 5,000. Right. You see. Now, you see in that why? Okay. Now it tell me that if you want to continue, right, enter the name, and if you want to exit, the enter again here. Right? So now if I think about I want to another one here, Brian here. I have 10,000. And of course now I do not want anymore. I exit. Okay, so see, now, right? I have the two employees here, right? The first one and the second one here, right? It makes sense. So we see now. See what is very important here is again very important here is this one. That is a step you got the name for the first employee. Without this one, you cannot execute the loop because the condition is not checked here. I see. If I delete this one here, if I delete this one, you see. When you go to the main module, right? You go to the check here, name equal to quit or not. You have no idea. The program have no idea what is name here. Right? That's why you got the syntax error here. See, you got the syntax error here. So, yeah, you got the syntax error here, right? And again, in the detail loop also, it's also very important. When you're done with the one employee, right? If you want to move to the next employee, the first step you need to get the name. And the reason that you need to get the name because it come back to check the condition. Makes sense. Now see, if I delete this one here, I run program again. Delete it. I have so what happened with this program here? I think it should be better. I don't find step by step here. I have David here, right? And now do everything for the David, right? Do everything for the David. I doesn't. Again, check with the rod, right? So it's the 10,000. But the thing you see, the name it always stays the David. Name always stays the David. And when you go back to this one here, the check here, the name is always in the David. It never ever equal to the again. That's why done it again and again forever. It's ended to here. So we see the thing is that it's very important here in the housekeeping you get the name, but in the detail loop also you need the action, right? You need the action to get the name of the next employee. It makes sense? Hello? Okay, so one of the way when you planning the program, when you break it down in module, you use a hierarchy chart here. And hierarchy chart, if you look on hierarchy chart, you know what is the relation between the module and how they relate together. In some program, you break it down in module, and in some module, you break it down in submodule. In submodule, you break it down in another submodule, right? So by looking at the hierarchy chart here, you see how they are related together. What is the connection? What's the relation between the module here? And again, a good practice in you do the coding is that you always try to use the comment here, and you have the header comment and you have inline comment also, right? And yeah, that is the inline comment here. Choosing identifier, that means very important, right? Clear statement. Sometimes you should use a temporary variable to clarify the long statement, right? So basically, from the computer point of view, when we execute the upper one and the below one here, they do the same. But from the programmer, it's way easier for him to follow what is going on in the program here, right? And the prompt also, prompt very important, right? Prompt important. Always make it meaningful to the end user here. So you should use the eco input. The eco input, that's what I mentioned on the last class here. The eco input, that means you get something from the input to deliver it in the output from here to make it more meaningful to the end user. Think about this one, right? Think about this one. Okay, so this one here, right? I got it here, right? I got the length, I got the width, I figure out area. I want to print it out here. I print out the area rectangle with the length, and this one here. See, I want to use the input here, length here, and equal input in the from output here. So I put it here, length here, and the width, and so I put it here. This one here, right? It makes more sense from an user if he want to follow what's going on here, right? So see, when I run this program here, right? When I run this program, I put the 20 here, and I put the number 10 here. So you see, it way better, right? You see, it's the program here. It's the program. I think it's better here, right? Too big. Yeah, you see in the program, the area rectangle with the length here. What's the 20? 20 actually it take it from the input from user, right? And what is the 10 here? It take it from the input from the width from the end user. It makes more sense to the end user, right? That is you try to use the input and put it in the prompt from the output to make it more sense, more meaningful from the user point of view. And remember, anytime if you have any question, you can interrupt me anytime. Right? For both of you and for the online student also. If you have any question, just let me know. Okay. Now, for this on the module 2 here, you also have some of the assignment. You work with the Python. The basically it's very simple assignment in the Python here, but I want to that's why I want to mention a little bit about the Python on this one. Now, in the Python, you know that if you want to get the input from the user, right? If you want to get the input from user, you have to build a function input. What I mentioned in the last class already, right? So basically, if you want to see, if you get the input here, right? So you put the gross here. That's the gross income, right? That's the gross income. And if you want to get the input from an user, right? So we use a function here, build a function here, input here, right? Should be better. I write in the Python, right? So let me review about the input, right? input from the Python here. So basically, you see, you have the gross here. It is a variable, the gross income, right? And if you want to get the input from user, you use the bring function here, input, right? And always try to make the prompt from input, right? And the gross income. Okay. And now, oh, sorry. And if I want to print it out. Sorry. Okay, so I put it 10,000 here. I print here. Gross here. Okay, so you see the bring function here is the input. Whenever you want to get the input from user, you use the function input here. But one thing is very important again. I have to remind you again that by the default, whenever you got the input from the function, it always in what? Is string format. It always is string format here. It always string format. Let me see here. Let me here. You can put the cross here. You see, you have the quote mark here. That means it's in string format. So now think about if you want to add my gross to the 1,000 here. If I do the gross here, I want to do 1,000. I got a syntax error. Right? The thing is that this one here in string format, it cannot add with the number here. Right? So here's the thing is very important here. In order to do everything with the arithmetic operation, whenever you got the input from the user, you have to convert it to the number format. Right? And again, you have two built-in functions here. The first one is the int function. You convert it into the integer number. Right? Or the second one is float function. You convert it into the float number here. Right? Think about this one here. Now I change this one here. Right? Change this one where my mouse. Okay. So slow. Okay, right? So think about this one. Now, so now I have to, if I want to convert it, remember that if the gross here is in the floating format, right? So I have to use the float here. Before that, to convert it into the number format, into the floating, right? And now you see, I can add them, right? I can add them with the 1,000 here. It's okay. So see, you print out the 11,000 here, right? This you can use a function here, float. If you want to convert it into the floating point, right? And if you want to convert, think about you have the dependent here, right? Dependent always in integer format, right? That's why you have in here int function here, right? Okay, make sense. So now the remind you, sorry, input here, not me. Remind you again here. When you work with Python, whenever you want to get the input from user, you use the input function. But again, remember, by the default, everything you got from input function is a string format. Right? And if you want to convert it into the floating point number, you use the built-in function float here. And if you want to convert it into the integer number, you use the int function here. Make sense? Any question? Now, that's the thing, right? So that is mentioned. It's a variable. Variable is a name represent the storage location, and you can use the assignment. Like put x equal to 10 or x equal to x to 10 plus 20 and so on. Any equation, right? And remember that variables, they are reusable, right? And when you got a new value, you override the old value here. And you can concatenate string and the number by using string str here, build function here. Now think about this one. I have salary here is the tag 1000. It is a number format, right? It's a number format. And I want to print it out here. Hello, your salary is, I want to print it out salary. If I want to concatenate them together, right? I have to convert again. This one is reverse in the reverse voice. I have to convert the number back into the string, and in order to concatenate the string together here, right? So see about for this one here. You think about this one. If you look on this program here, I just copy it. This one. So see, basically you see, if you do that one here, if you do not use the string function here, when you run it, you have the syntax error, right? You see, the syntax error here, type error, you only able to concatenate string to the string only, right? But this one here, everything hello, your salary is something, you put it under the double quote mark, it is string, it's string. But the salary, what is it? Salary here is 1000 is the number format. That's why you cannot concatenate them together, right? So in order to concatenate them together, you have to convert this one here to the string format. And in order to do that, you use the str function here. You use the str function. So now, okay, run. So make sense? Okay, and of course, in the Python, you have many ways to print out the output here, right? So or you can change this one if you do not want to use the string format here. You use the comma here, right? You put the comma here and print it out. That. But you see, you have the space here when you use the comma here. Or if you do not want to use the space here, only you can use the separation here. Set here equal to. You do not want any space between them. Okay, same, right? So actually, in the Python, on the same problem, you have many ways to represent it. But again, that I want to understand the purpose of the. I want you to understand the purpose of the string function here, right? That's why I use the string function here. Okay. Any questions so far? Let me know.
Yes. Will the program run if you use salary equals integer?
No. The salary here already in the integer format. The purpose here, you want to convert into string format, right? You want to convert in string format here, not the number.
Oh, okay.
You put it here now, it's okay. If you put it here, this one here, right? It does the same. It always provides the integer number here, right? So you want here in the string format, not the number format. Right? That's why you have to put the string function here in the salary here. Okay, see, if you do this one here, it's not work, right? Because again, salary here is still in the number format. Yeah, make sense? Clear?
Yeah.
Okay. Now I think we move to some of the universal markup language here, and we have some video to show. Yeah, this one.
diagrams. We'll start with a high-level overview, then we'll talk about systems, actors, use cases, and relationships. And finally, we'll build an entire use case diagram together and go over examples to explain these concepts in depth. Have you ever had an idea that makes perfect sense in your head, but when you try to explain it to someone else, they're completely lost? Maybe your idea is for a new app, and every time you talk about it, people don't really understand how they'd interact with the app or what it would do. This type of scenario is where a use case diagram is very helpful. Here's a simple description of a use case diagram. First, it shows a system or application. Then it shows the people, organizations, or other systems that interact with it. And finally, it shows a basic flow of what the system or application does. It's a very high-level diagram and typically won't show a lot of detail, but it's a great way to communicate complex ideas in a fairly basic way. Before we really get into the tutorial, let's talk about how you're going to make a use case diagram. You can draw them out with pen and paper, but a diagramming application is going to be much easier. Today I'll be using Lucidchart, and you can too, for free actually. Just click the link to access Lucidchart's website. Enter your email address, and you'll have a free Lucidchart account in just a few seconds. It's easy to use, and you can follow along with me as we build a use case diagram. Okay, so we're going to break down use case diagrams into 4 different elements: systems, actors, use cases, and relationships. Let's start with systems. A system is whatever you're developing. It could be a website, a software component, a business process, an app, or any number of other things. You represent a system with a rectangle, and you put the name of the system at the top. We're going to build a use case diagram for a very simple banking application. We'll call our system Banking App. This rectangle helps define the scope of this system. Anything within this rectangle happens within the banking app. Anything outside of this rectangle doesn't happen in the banking app. The next element is an actor, which is depicted by this stick figure. An actor is going to be someone or something that uses our system to achieve a goal. That could be a person, an organization, another system, or an external device. So who or what is going to be using our banking app? The most obvious actor is a customer. We are going to have customers that download and use our banking app. Another actor that we'll want in our diagram is the bank. The bank is going to provide information that feeds into our banking app, like transactions and account balances. Here are a couple things to keep in mind when dealing with actors. First, it's important to note that these actors are external objects. They always need to be placed outside of our system. Second, actors need to be thought of as types or categories. For our banking app, an actor isn't going to be a specific individual or a specific organization. We wouldn't label our actors as John and Chase Bank. We want to keep things categorical. So right now we're saying that both customers and banks are going to use our app, and this brings up the topic of primary and secondary actors. A primary actor initiates the use of the system, while a secondary actor is more reactionary. So in our example, which actor is primary and which actor is secondary? The primary actor is customer. The customer is going to initiate the use of our system. They're going to pull out their phone, open up our banking app, and do something with it. Bank, on the other hand, is a secondary actor. The bank is only going to act once the customer does something. If the customer goes on the app to see how much money is in their account, only then does the bank engage with our system to provide the balance. Primary actors should be to the left of the system, and secondary actors should be to the right. This just visually reinforces the fact that customer engages with the banking app and then the bank reacts. The next element is a use case, and this is where you really start to describe what our system does. A use case is depicted with this oval shape, and it represents an action that accomplishes some sort of task within the system. They're going to be placed within the rectangle because they're actions that occur within the banking app. So what is our banking app going to do? We're going to keep things very simple. Our banking app is going to allow a customer to log in, check their account balance, transfer funds between accounts, and make payments towards bills. So if this is what our banking app does, we're going to have use cases that describe each of those actions. We'll have a use case called login, another called check balance, another called transfer funds, and finally make payment. You can see that each of these use cases starts with a verb and reinforces an action that takes place. We also want them to be sufficiently descriptive. If this use case just said transfer, that'd be too vague. Finally, it's good practice to put your use cases in a logical order when possible. That's why we put login at the top. That's the first thing that will happen when a customer uses our banking app. The final element in use case diagrams are relationships. An actor, by definition, is using our system to achieve a goal. So each actor has to interact with at least one of the use cases within our system. In our example, a customer is going to log into our banking app. So we draw a solid line between the actor and the use case to show this relationship. This type of relationship is called an association, and it just signifies a basic communication or interaction. A customer is going to interact with the rest of these use cases as well. They're going to check balance, transfer funds, and make payment, so we'll draw solid lines out to each of those as well. Secondary actors will also have relationships. Remember, each actor has to interact with at least one use case. So which use cases will the bank interact with? When a customer wants to check their balance on the app, the bank is going to provide the correct amount. Let's draw a line between bank and check balance. Similarly, when a customer wants to transfer funds or make a payment, the bank is going to follow through with those transactions. We don't need to draw a line to log in because that process happens within the banking app. There's no need for the bank to actually get involved with the login process. There are 3 other types of relationships in addition to association. There's include, extend, and generalization. Let's build out this diagram with additional use cases in order to explain these types of relationships. When a customer types in their login information, our banking app is going to verify the password before completing the login process. But if the password is incorrect, the banking app is going to display an error message. So let's create 2 new use cases for verify password and display login error. When a customer wants to transfer funds or make a payment, our banking app is going to make sure there's enough money to complete those transactions. So we'll also create another use case called verify sufficient funds. And finally, when a customer wants to make a payment, our banking app is going to give them the option of paying from either their checking account or their savings account. So we'll create 2 more use cases called pay from checking and pay from savings. Let's circle back to this verify password use case and talk about relationships again. How does verify password relate to the rest of the diagram? Neither of our actors are directly initiating this action. It's just immediately going to happen within our banking app every time there's an attempt to log in. This is an include relationship. An include relationship shows dependency between a base use case and an included use case. Every time the base use case is executed, the included use case is executed as well. Another way to think of it is that the base use case requires an included use case in order to be complete. When you have an include relationship, you draw a dashed line with an arrow that points towards the included use case. So in our example, login is the base use case, and verify password is the included use case. Every time a customer logs in, our banking app will automatically verify password. This login use case won't be complete unless verify password is complete. So we draw a dashed line with the arrow pointing towards the included use case, and we write include in double chevrons. The next type of relationship is the extend relationship. An extend relationship has a base use case and an extend use case. When the base use case is executed, the extend use case will happen sometimes, but not every time. The extend use case will only happen if certain criteria are met. Another way to think of it is that you have the option to extend the behavior of the base use case. When you have an extend relationship, you draw a dashed line with an arrow that points towards the base use case. In our example, login is a base use case, and display login error is an extended use case. Our banking app won't display a login error message every time a customer logs in. This will only happen once in a while when a customer accidentally enters an incorrect password. Since this is an extend relationship, we draw a dashed line with an arrow that points to the base use case and write extend between double chevrons. Hopefully, this thoroughly explains the difference between include and extend relationships. But just in case, here's a very basic example to help differentiate between the two. If you sneeze, you will close your eyes. That's an included relationship because it's going to happen every time. Additionally, if you sneeze, you might say excuse me. That's an extended relationship because it supplements the sneeze, but isn't completely necessary in the sneezing process. Just remember that include happens every time, extend happens just sometimes, and don't forget that the arrows point in opposite directions. One quick thing to note is that multiple base use cases can point to the same included or extended use case. For example, both transfer funds and make payment are going to point to verify sufficient funds as an included use case. We want our banking app to make this check every time either of these base use cases occur. You don't need to duplicate the verify sufficient funds use case. The simpler your diagram, the better. The last type of relationship we'll discuss is generalization, also known as inheritance. When you make a payment from our banking app, you can do so from either your checking account or your savings account. In this scenario, make a payment is a general use case, and pay from savings and pay from checking are specialized use cases. You could also use the terms parent and children. Each child shares the common behaviors of the parent, but each child adds something more on its own. To show that this is a generalization, we draw this type of arrow from the children up to the parent. You can have generalizations on use cases like we have here. You can also have generalizations with actors. In certain scenarios, you might want to distinguish between a new customer and a returning customer. You can make them both children to a general customer actor, which would allow you to have certain behaviors or qualities unique to each of these children. One last shape that we'll quickly talk about is a use case with extension points. You can see an example here. The name of the use case is above the line, and then there are extension points below the line. Extension points are just a detailed version of extend relationships. This use case shows that a customer can set up their profile in our banking app. And then these extension points show us that when a customer is setting up their profile, they'll have the option to navigate to a couple different screens. If a customer is confused, they can go to Profile Help. And if they want details regarding their private information, they can go to Privacy Info. Those extension points branch off to extended use cases. Go to Profile Help and show Privacy Info. We can even add a note to show what sort of conditions would lead to these extension points. Now we have a complete use case diagram with various elements that help explain what our banking app does. This is a very basic example, but remember that even complex systems should be restricted to a simplistic visualization of functionality, behavior, and relationships. If you'd like to take a closer look at this example, click on the card in the upper right-hand corner. You'll find.
Okay, so I think that is very, very good video for you to do with the discussion here, right? So this is a user curry diagram. It's one of the types of diagram where we work with the universal markup language. Very helpful in the curry you do with the planning step here, right? To show how the relationship between the actor and how they relate them together. Yeah. So basically, you have the system, right? You have the actor, you have the use case, and you have the relationship. And in the actor, you have a primary actor, it's the one who initiates the user system, and you have the secondary actor, is who reacts, right? And also we have a sum of the relationship. You have to include, so always go together. You have to exclude sometime, right? And you have the generalization and so. So I think that is that by doing one more thing about this one here. For this discussion, right? So if you want to draw it, you use the draw IO here. And it's draw IO, and they already have a template for this one here. That's the template, right? So we have to download the template. You save it to somewhere and download it. I save it to that. So from the draw IO, where am I draw IO? That's this one. Right? Right, and I save it. I open existing here. I save it in the download, and I click on this one. I open it here. So basically, for this one, you will have the template. You have the score registration system. And what do you think? What's the actor here? What is the primary actor and what is the secondary actor? What's this one? What do you think? Student primary. Yeah, student the primary, right? and the secondary is radical of which, right? I think so. Honestly, I'm not really sure about the registration process. That's why I'm not really sure about this one. And anyway, it totally is up to you. And you do not have the same same output with this one. You can think about the process here. Okay, so try to integrate action and try to integrate the relation between them. I use the include, extended, and general action in your work. Now I come back with the homework here. Now we do some. Let me open some of the debugging exercise. And one more thing about the debugging exercise. So normally the number 4 in every debugging exercise in the flowchart, right? So again, I mentioned on the class you have multiple ways to do that. You can use a draw, and you can correct it in the pen here, right? Or you can use a flowchart. Sorry, you can use a draw.io. You redraw it, or you can use a Microsoft Word, or you can use you can use a Rapid also, or you can use a blank paper. User draw it. User need the blank paper and the pen, and they redraw it, and you take a photo and have it submit. But remember that you only do that for the number 4 only. For every other exercise, number 1, number 2, and number 3, you are expected to do with the pseudocode. You are expected to do with pseudocode. And one more thing I have to highlight here: in all the pseudocode exercise here, you are expected to do with the pseudocode only. I know that some of you you understand how to work with the Java, or how to know how to work with the Python here, but do not convert it to the Python and Java. This exercise here to test or understand about the pseudocode, right? So always follow the pseudocode format. Do not convert it into the Python or Java. Any question for this one? Yes.
For the number 4, can we
Yes, number 4. You
use pseudocode?
Yes. Okay. You can. Oh yes, right. You can use the pseudocode itself for the number 4. I think I made it in the announcement already. I made it in the announcement. Yeah, you have some of the option here. It totally is up to you, right? Now, let me see. What is it? Oh, this one very simple. So now, this pseudocode segment is intended to compute and display the average grade of the 3 tests. If you look at this program, what do you think? What is the expected output here? What is the expected output? What is the expected output for this program? What do you think? Average. And in order to figure out the average, what are the input here?
3 tests.
Yes, 3 tests also, right? Now you see, it follows exactly the same structure here. Sorry, the same type the coding here, right? At the beginning here, you declaration, right? You need to see the test number 1, test number 2, test number 3, and average they are in the number format. But remember here, yes.
So shouldn't the average have like brackets like test 1, 2, and 3? Wait, is this oh yeah, sorry. This is debugging. Sorry, yeah, I shouldn't have answered that. Sorry for that.
No, it's okay. Yeah, you are the one who find out what's wrong with it, and you are the one who correct it, right? And that's good, right? So here's the thing here. Remember that remember one thing about in the pseudocode, right? Remember one thing in the pseudocode here. Try, you have to something is a common mistake here. The first one is the inconsistent variable name, right? That's the thing. That is the common mistake here. And if you look on this program, what's wrong with this program here? What's wrong with this program? What do you think? What's wrong?
Test2 is there twice.
Yeah, right. You need three variables: the test number 1, test number 2, and test number 3. And you have to declare at the beginning, right? But you see for this one here, if you see for this one here, test number 2 and test number 2. Okay, it's not correct. So basically, this one number 3 here. Right? This one you have to correct in number 3 here. Now you get the input for the test number 1, get input for test number 2, get input for the test number 3. You figure out average, and you are correct, right? You have to put everything here inside the parentheses. Otherwise, it's not correct here, right? You add them up together and you divide by 3. Otherwise, you see for this one here, you have the 60, right? You have the 60, you have the 70, and you have 80, and you expect the average here is 70, right? But you see, if it's this one here, how it works? You have 60, you plus the 70, sorry, plus the 70, and you plus the 80 divided by 3 here. Totally wrong. This is one, right? So that is very simple one here. That is simple, very simple. Okay, this one here, see, this one is we learned something about the structure, right? We learned something about structure already. So for this one, you see, it follows the structure here. This program here intend to compute and display the average grade of 3 tests for any number of students. The program is secure until the user enters negative number for the first test score. Right? So if you look on the first one, in the first program, you only figured out for only one student. Right? But this one here, you do the loop. So you can do it for 1 student, 2 students, and so on. You do the loop, and you see it follows exactly the same structure here, right? Same structure here. You see, at the beginning, you do everything with declaration here, right? Do everything with declaration here, and if you have the constant, you do the constant here also, right? Now, housekeeping. What is housekeeping? Housekeeping is a step to get ready for the loop. You need to get it. So what is get it here? Housekeeping, you need to get the score number 1 of the first student, because you see the program execute until the user enters the negative value for the first test score. That means it is test number 1 here. Check if test number 1 equal to 0, you exit the loop, right? If not, keep doing it. So see. The housekeeping here, you need to get the test number 1 of the first student. In order, you go to the loop to check the condition. Right? Okay. What's wrong with this one here? What's wrong with this one? What do you think? When you call the housekeeping here, you jump to the housekeeping. But what's wrong with this one?
It needs to be, if it's equal to 0, not a negative number to quit.
Enter the score for test number 1 on negative number to quiz. It's correct. The problem here is correct. But remember here. If you look on the adapter here or the pseudocode, right? Or the pseudocode adapter here. What's wrong with this one? Now see. In every program, right? In every program, if you want to get the input from user, you need to use the prompt, right? You need to use the prompt, and after you got the value from user, you have to store it into the variable. I see. If you look on this one here, this one is the prompt only. This one's a prompt only. Tell user what to do. But after thinking about he enters the number 20 here, you have to do the action to store number 20 into the variable name. here, right? So if you look on this, if you look back in the program here, if you look back in the program, this one here, this one only has the prompt, right? Only has the prompt. Output here is only prompt. You need to store it into the variable, right? So for that one, you need to input here. You need to you need to, let me see here. You need, right? You need to get stored into the input and you store it into the text. Make sense? Right, if you see, if you go back to every other program here, you see, whenever you got the problem, right? Whenever you got the problem, you have to store it into the variable name. Right? Make sense? Any question for this one? Okay, so see, for this one here, you only have the prompt. You don't have you do not have the action to store it into the variable here. That's why that's the first mistake here. But that's the first error here. Right? Now, again, you have housekeeping here. Right? Now, check if you got the enter. So think about the user. User got the number the 60 here, right? 60 here. So housekeeping, right? When you see housekeeping here, done, right? Got the 60, you go to the loop here, right? Why set number 1 greater than or equal to 0? And you have a 60 here, the correct, right? Do the loop, you go to the main loop here. What's the main loop? You jump it back, you jump it to the main loop here. Right? You got the tab number 2. What's wrong with this one? What's wrong with the main loop here? What do you think? What's wrong here? Hello? The active guy. What's wrong?
It doesn't ask for test 3 at all.
Yeah, right. In order to figure out the average, you need to test number 1. Test number 1 already here, right? Out of the loop. Now you need the test number 2. You need the test number 3 also. This one only has the test number 2. It's not correct, right? Now it print out, right? It print out the average here. It print out the output here again, right? Something wrong with this one. It's a consistent here, inconsistent, right? This one is test number 1, not test number 1 here. And see, it follows exactly the structure here, right? When you done everything with the when you done everything with the one student, if you want to move to the next student here, you need to get the first step of the next student here, right? In order to check the condition of the loop. Otherwise, always stay with the test number 1 of the first student. I see it follows exactly the same structure, right? You have the housekeeping, get initial value, you check that condition. And inside the body of the loop, if you want to move to the next student, you need to get the test number 1 of the next student here. So remember, the test number 1 here is the test number 1 of next student. Make sense? Hello.
Yes, it makes sense.
Okay. And here's the same. Here's the same. So I just want you to understand about the structure of this one. So go back to this one. It's very important. If you understand this one structure here, you can do anything with the pseudocode. Right? You can do anything with the pseudocode here. See, you have housekeeping. Right? What's the housekeeping here? You got a name. Actually, name here is the name of the first employee. Right? But again, you see, inside the loop here, again, you got the name again. But the name here is the name of next employee. The same with the program here. You got the test of the first student, right? But inside the loop, you need to get the test number 1 of next student here. Huh? Do exactly the same. So try to understand this logic. Try to understand this structure. Once you understand this structure, you can see everything going wrong with the pseudocode program here. It's a debugging process. No, I do not want to do it for you. I want to reserve some work for you.
I do have a question about
Yes.
the syntax. Is the declaration should it be a note sort of thing, or should it be, or is it a legitimate declaration.
What declaration?
Uh,
Declaration.
Yeah. So here,
Declaration.
yeah.
Not declaration.
Yeah.
Declare, that means it declares the variable here.
Yeah,
Okay.
should that need a note, one of the slashes by it, since it's not in and of itself a variable?
Which one? This one?
Yeah, so here, should it have one of these here?
Is a declaration?
Yes.
No, you
No.
don't need. Yeah,
Okay.
this one.
Okay.
It tells you that it's a. You can think about this. It's a module. And you can
Okay.
think it's a module, and inside you have the. And you remember that in the pseudocode normally you have the two category here. Num that means for the number format,
Okay.
and string that was string format. That's all.
Okay, so that just
That's okay.
allows it. Okay, syntax. Thank you.
Now we have the raptor here. So basically, the raptor is very simple here, right? So the first one, the first program here, you got the number, and print out the number times 10. That's all. And if you watch a video, a recording, or if you join the class on the last class here, right? You have the same problem, you time by 2, but this one time by 10. That's all. And the second one, you have the two value, right? You have to calculate the sum difference and the multiply of the two numbers. So very simple. But here's the thing here. To get the maximum point, you should use the equal input here. And you know what is the equal input, right? I mentioned it on the class here. Okay? It's very simple. And if you need any help with this one, let me know. Otherwise, I suppose that you understand this one. It's very simple here, right? You need any help? No. Okay, so the Python, let's see what you have in Python. Okay, sorry. I just this the chart here. You have the question, very good question here. You ask me what is the difference between the integer and floating, right? And remember, the floating number is the number you have the both of the decimal part and the fractional part. You can think about this one here. You can think about 10.0.57 here. That is floating number. That is float number, right? But if you have the 10 here, it is a integer number. It's a whole number only. Integer number is a whole number. So we think about this one. When you want to get the gross income, it must be in the float, right? You might have the 10,047 or something like that, right? But when you want to get the number dependent of each employee, right? So you might have 1 children, 2 children, it must be the integer number. Right? That's all. And remember one thing here, if you have 10.0, it's not the integer number. It is a fractional part. It's a floating point here, right? Because it has both. It has both of the decimal point and fractional point. Even the 0.0, it is a floating number. It's float. So just remember that the integer number is the number you only have. It's a whole number. You only have the decimal part of it, right? But in the fractional part, you have both of the decimal part and the fractional part here. It makes sense? Okay, so this program is very simple, right? So here, assign the integer number name, it's your current age here. So basically, this one you even do not get the input from user initialize here, right? So we can think about here, assign the integer variable name. So we can put it here and assign it to the dot. Assign to the edge here, right? So we can put it it's the field, right? You can put this 40 or 70 here or whatever here, right? And aside also, you drag and drop it, right? And put it here, 2022, right? And execute program. That's all. That's very simple here. This one you don't have to get the input from user. So you see, you have the string function here, right? Because you want to concatenate the text with the number here, right? That's why you have to convert this one to the string format and you concatenate them together, right? Any question for this one? Hello?
No questions.
Very simple, right? Yeah. So what else? Okay, this one here. This one for this program, I can right? You had the retail price as a wholesale price, item name. But one thing about this one here. One thing about this program here, you see, in this program, right? In this program, you have the calculate the profits, calculate the sale price at 25% deduct from the retail price. Right? So see the 25% here, you can think about constant here, right? Constant here. So it's a good practice of the coding that you define the constant name and you put at the top of the program, right? So you can think about you put it here, deduct here. You put everything in the uppercase, right? Deduct, and right here. Oh, they have to wrong. So we put 0.25 here, and later on you can call out the constant name, later here, right? Because in the mention in the class I mentioned that try not to avoid the magic number. The magic number is a number no name here, right? So try to use the constant name for this one. That's a I mentioned on the class last time, right? For the router, you only need to require to do the header command. You do not have to do with the inline command, otherwise very confusing. Right? So in the router, you only need to do with the header command only. You don't have to do it with the inline command. Now this one also is very important. Sorry, this one also very simple, right? So it's again, you see, you have some of constant here, right? So we can put here, you can put the state rate or federal rate, and that is the constant here, right? But one thing about this one here, one thing about this program, you see in this program you put the salary here and the number dependent here, right? So this program is fixed with the salary and the number dependent, right? In this program here. But when you go to the end of the program here, right? What is it? See, in this program, the variable name, salary, and the number dependent are initialized with the number 1,250 and 2 here. Now they ask you to more flexible, right? By modifying a set interactive input from salary. So in that case, you need to get. Sorry, what's the question? Hello. Okay, so in that case here, you need to get input from the user, right? You see, for this one here. For this one. I initialize with this one and this one, but you see, to make this program more flexible, modify it to accept interactive input. What is it? The program here want you to get input from user. It's not always fixed to this one, not always fixed to this one. So in that case, you have to use the input function here. So we see you put the salary here. Salary, right? So we put here. Of course, you have to convert it into the code, right? Now let me do it here. I want to draw it. So see, to make it interactive from the user point of view, you put the salary here and it's a float here. And it's do here and your okay, so see, by doing this, right, you give the user option to change his salary, right? It's not always fixed to the 1,250 here. He might enter the 300, 3,000, or 4,000, or 5,000. It totally is up to him, right? That is interactive input here. And also, also for the dependent also. Okay. So what do you do with the dependent here? What do you say? What do you do with dependent here? You have to input here. Sorry, my mistake. Yeah, and dependent you do the same, but remember salary is the float format, right? But dependent is integer here. That's why you have to do everything just integer. And the number of your dependent. Okay, and you see on this one, you copy it, this one, and you put at the top of this one here. Right? Put at the top of this one here. So see, it gives the user the more flexible. He can change the salary, he can change the number of dependent. Make sense? Any question? Hello. Okay, so if you have no question, I think that's all for today. Let me check the attendance here. Okay. Okay, are you here? Huh? Let me see if he's online or not. That okay here? Camera, are you here?
I'm here.
Okay. Yeah, here. Rickman, are you here? Yes, sir. Emiliano.
Here.
Okay. Riley, are you here? Why you have no audio? Riley, are you here? Can you hear me? Riley. Hayden, are you here?
Yeah, I'm here.
Last one here. Look, are you here?
Yeah, I'm here.
Diego, are you here? Oh, sorry, yeah. Nick, to make it short, I call him Nick. Sorry for that. I'm very hard to pronounce. Nick, are you here? Oh, Hamut? No. So I think it's too far from the microphone, right? But hello, the other guy, can you hear me? Hello.
Did you say my name?
Yes, I did.
My name is Nikunj. I don't know if you said that or not.
I call you Nick. It's very hard for me to pronounce. So I
Oh,
call-
okay.
Is that
Oh, okay. Yeah. Yeah. I was just like confused that whether you said my name. Yeah, I'm present. Just making sure.
Jack, are you here? Yes. Jose, are you here? Jose.
No.
Here or not?
Yeah, I'm here. Can you hear me?
Yes. Martin, are you? Martin, are you here? Hello? Yes. Shalon, are you here? Shalon? No. Nathan, are you here? Nathan, are you here?
He said he's here and he said he was there in chat. Wait,
He on the chat, but he actually not engaged in such class here. Why?
he says audio is not working.
Okay, that's got it. Anyway, I paid your name here already. So I see you guys on Tuesday, right? And remember that format on Tuesday try to study ahead. I look what is going on with that. Sorry, what you cover in the module 3, and I already have the upload both of the slide in the learning activity, so you guys can learn it in advance. And if you have any questions, just let me know on Tuesday. Right? Better for both of us, better for me, and better for you if you study something in advance. So we have something to discuss to talk about this. Okay. Bye bye. Bye guys. Bye bye.